Hey everybody, this is going to be one of the several videos that I'm going to provide for the benchmark walkthrough, just because it is kind of massive and I want to break it apart into decently sized chunks instead of having like an hour of video. So this first video is going to be 1 through 6. I'm just going to go ahead and go through it. Number one, long distance phone company charges $15 a month plus 5 cents per minute for calls. That per minute is going to come back into play here. If a family's total monthly bill is total monthly bill is $51.90, which has $17 included for internet. How many minutes did they use? So minutes is what we are going to look for. In setting this up, there's two ways that I saw it set up today in class. The first way was understanding that the $17, since it's included for internet, we can take that out of our equation. So I did see it look like this when setting up the equation: $15 plus the 0.05x, which would be the minutes, I guess, set equal to $51.90 minus 17. So you're taking out that 17 from the equation. So that was one way to set it up. Another way I saw it was basically, and this is how I told you guys to do this during the equations unit. Typically for equations, you're going to have a total, and then you're going to have what makes up that total. So another way to do this is what makes up that total, the $15 plus the 5 cents per minute. And then also the $17 makes that up. Okay, so also that $17 makes that up. And that is going to equal the total bill of $51.90. So there's that. Okay, so two ways to kind of set this up. Now we actually have to solve it. I'm going to kind of do this as quick as I can, I guess. On this particular equation that I have here, I'm going to take $15 plus the $17 to get $32 plus the 0.05x, and that's going to equal to $51.90. From here, I'm going to subtract 32 from both sides to get 0.05x equals 51.9 minus the 32. I got 19.9. Okay. And then the last step is to divide by 0.05. And we should get our solution of 398. Okay, so 398 is the one that we're looking for. That seems to be A. So A is our solution here. We can solve this one as well. Not a ton of room here. Well, we'll just go through it. We'll be okay. I'm going to add 17 on both sides. So essentially, by us adding 17 here, that was like that first step of combining like terms on the other equation. So that'll give us 32 plus the 0.05x equals 51.90. At that point, we should have basically the same thing. So I'm just going to copy exactly what I did. I know, magic of technology here, but I'm going to copy exactly what I did because that's what I would do. And do this. It's just going to save a little bit of time. So this is what we would have in that first equation. All right. So you're going to end up doing the same thing. You still get the 398. That is the first one. That takes care of that. All right. So 398 is number one. Number two, which number is closest to point A? So this is the one that we're looking for number two. We need to figure out which one is closest. You can estimate. What I was encouraging folks to do today is just use a calculator. Okay, use a calculator. Now, this one is in the negative area, so you can cross out C and D because those are both going to be positive. So what I might do between these two is just put them into a calculator and see, because comparing decimals is a little bit easier than comparing, especially this irrational number 6. So negative 3/4 is negative 0.75. So B is going to be the one that's closest to point A. All right. These B, C, D, E up here, they don't mean anything, so don't worry about those. But yeah, there we go. That's number 2. Number 3, we need to order these numbers from least to greatest. So again, I'm going to kind of compare these with decimals. So negative 11 divided by 6, this is negative 1.83. Repeating. Square root of 19 is about 4.36. 0.23 is still 0.23. That's not going to change. 6/5 is 1.2. And negative 2 is still negative 2. So from least to greatest, we're going to start with negative 2. Negative 2 is the smallest number on here, so that immediately eliminates A and C. After negative 2 comes negative 1.83, which is the negative 11/6. And I see that B already has that in the right order. Assuming that everything is good, 0.23, that's a decimal. Then you got 1.2. Then you got, yeah. So B is going to be the correct solution. And we didn't even really have to go through those. What I'd recommend is doing what I did here at the beginning, just setting up your, or kind of getting your decimal form in those numbers so you can more easily compare them. All right? That is 3. Number 4, estimate the value of negative 3 pi squared. So a couple things here. Pi is about 3.14, right? So this 3.14, and this is me estimating. You can put this in a calculator, which is what I'll end up doing. But this 3.14 looks like 3, so we can substitute that 3 in. So this 3 here is about what pi is. Then we do exponent in terms of order of operations. We do exponents first. So 3 squared would be 9. So then this becomes negative 3 times 9, which would get me a negative 27. If that is the case, C is going to be what we need to have. But let me go back and I'm going to put this in my calculator. The negative 3 pi, if I can find pi, there it is. Okay, negative 3 pi squared. I actually get negative 29.6, which would indicate that this is correct. So if there's a question like this on your test, I would take either. Because if you do them a different way, if you either estimate, you're going to get one answer. If you plug it into a calculator, you'll get the other answer. I believe on your test, it's not as close as it is on number 4. So do not stress yourselves out about this. It'll work. Whatever the numbers will be will work with the options that you have. Okay. Number 5, largest number. So I'm going to do similar to what I did on that ordering problem. Just kind of get all of these numbers first. So the square root of 45 is about 6.7. 5 pi is 15.7. Okay. 1.45 or 54 is still there. And 3 square root of 3 gets me 5.2. Which one is larger? It's going to be the 15.7, so that 5 pi number is the one that we're going to use there. All right? So that is number 5. Number 6, classify the given numbers as rational or irrational. So this was way back at the beginning of the year. It was definitely in 7th grade. Rational and irrational. Here's the way that you can determine which is which. Okay. Rational numbers are going to be either fractions or can be written as fractions. Let me write that. Can be written as fractions. Okay, so that's one thing. And then also these are repeating or terminating is what we call it in math terms, which just means ending decimals. Okay, so these are rational numbers right here. Irrational is going to be anything that's not those. So we'll go kind of one at a time here. 6/7, that is a fraction. Rational numbers can be written as fraction, therefore 6/7 is rational. Pi. If you plug pi into your calculator, or just know, we should kind of know what pi is already. We'll work with it a little bit later this year, but pi, we use 3.14, but the symbol pi actually itself is a non-repeating and non-ending decimal. So pi is actually irrational. It's a terrible pi sign, but that's okay. 0.81, this bar right here says that this is going to repeat. This is repeating. So this one would be rational. It is a repeating decimal. This fourth one that we have here, the negative 3.82353, with what we're given in that, we don't know if it is repeating. It is definitely not terminating or ending because of these three dots here. So we don't know. Yeah, we don't know if it's repeating. We don't see a pattern, so this is going to be irrational. Negative 3.823, and so on and so on. Okay. Square root of 42. Anytime you have square root numbers, the only ones that are rational are your perfect squares. So for 42, you can't think of two numbers that are exactly the same that you can multiply together to get 42. Therefore, the square root of 42 is irrational. Okay. If you put that in your calculator, you'll get one of those non-repeating, non-terminating decimals, like that negative 3.8 number. Okay. And then the last one we have is negative 9. You might think that because it is negative, it's going to be irrational, but you can make any number into a fraction and have it still mean the same thing. So negative 9 over 1 is still negative 9. So since that is a fraction, negative 9 is rational. Okay, and that takes care of 1 through 6 on this first video. I'll kind of release these as I get them done, but there's 1 through 6.